well, currently I'm the tech lead at Lautsprecher Teufel, a company that we produce and design our own speakers and home cinemas and all these sound-related products. And we use Spryker, actually. And that's also, I got a lot of experience from Spryker since then, about 3 years already. I am also an open source contributor of the Fairland project and also Gacela, the creator of it. And my area of expertise, I will say, is about solid principle, TD mentality, philosophy, or way of writing software, and agile values. But yeah, let's start with why. Why Gacela? I think this is a project that gives you the experience of a Spryker modularity in any project that is not a Spryker. So this is really cool for Spryker developers because you can actually use all your knowledge that you use in your daily business in all other non-Spryker related core. And so it helps you split the logic of your application into different modules, like Spryker does with 100 of modules actually. And Gacela was born as a result of a lot of restructuring and refactoring of another open source project, which I mentioned earlier, which is Fel. And it is a open source software, totally, with a mid license, so you can use it whatever you want. And this is perfect for newbies and experts. So I think the scope is really bright in this case. So for newbies, because it helps you grasp the basic concept of Spryker modularity, and then you have a smoother and faster learning curve because you focus on understanding the fundamentals, fundamental modular logic in isolation. So you don't need to worry about the hundred of modules and the complexity behind these modules in Spryker. So it's from a really isolated scope, you can understand the first foundation. And then once you grasp this, you can use this knowledge into a real Spryker application. And the other way applies. So for expert, it's really cool because it feels that you are working on a Spryker project on any non-Spryker project. So you can actually help using this knowledge of splitting the logic into different modules and then splitting them by layers, as we will see in a demo. And then, so yeah, this is I think it's a really cool win-win for everyone in the community. It uses the facade and factory pattern that you have seen, and you are, I'm 100%, I hope everyone here is more or less aware of these two patterns, so I'm not gonna go inside this too deep, but the facade and factoring are really a common pattern in the industry of software that Spryker uses on every module. And this is the thing, this is Gacela. These are the 4 things that you need to just simply know. They are way more technical, like we are going to see, but this is the abstract foundation. So the modules interact with each other only via their facade. And the facade is the entry point of the module. And then you have a factory, which manages the intra-dependencies of the modules. Then you have the dependency provider, which resolves the extra dependencies of the module. And then you have a special class, which is a config, which has access to the project config files. And this is like the basic Gacela structure. So you might see here, we have inside the source, you have a module A, whatever. Then you have domain application infrastructure layers or business persistent, whatever you want to call it. And then you have this. These are the only 4 classes that are useful, let's say, that are working, that are the Gacela classes, I call them, which are right on the root of the module. And then you might have module B, module C, module whatever. And then, so what you are capping yourself when you are using Gacela is to simply have these 4 classes inside the module. And whatever you want to have in your domain, in your application or infrastructure is up to you and yourself. So I don't mind, Gacela is not going inside. Gacela is just helping you to manage all of the complexity here and the communication between different modules. So I want to tell you, how can you start and what is the minimum requirement to actually start using Gacela? It's just this line here above. Gacela Bootstrap. So you just need to simply say, where is the entry point? Where is the root of the application? And then from there, Gacela will work out everything. And out of the box, you can actually customize a lot of things that we're going to see in this talk, a lot of things that Gacela does by default, but you can play around and have a lot of gain. So, how can you customize or configure the configuration of Gacela, let's say? There is a callable as an optional second argument to the Bootstrap, or even you can create a Gacela.php file next to the index, so in the root of the level, of the project, and then you return the callable, so it's the same. This is identical. You can have it however you want. And there is even, we will see later that you can even have different environment for the Gacela, which is the next slide. So the benefit of having a Gacela.php is that you can have different configuration of Gacela for depending on the environment. So this we'll see later that you can configure depending on if it is in your development environment or production environment or anything environment that you want to have, staging or whatever you name it. You can have different configuration for Gacela. So let's start looking at, okay, what can you actually do with this configuration Gacela config? Yeah. So for example, you can define where are the application configuration key values file. So for example, where are your secrets and all of this. And in Spryker, you can only have PHP, but in Gacela, you can actually have whatever you want and whatever you want. So you can specify as many app config readers with any type. You can even create your own, extending implementing an interface, and you can have by pattern. You can say, okay, all PHP files that are inside the config directory are part of the app config. And there is also a local, which is similar like what we have in Spryker, which is config_local, which is ignore, and then you can have your own custom things to play around. So you can have a local for each family path of configs, and then you can have the YAML config reader, I will say XML, no, well, yeah, also, but whatever config readers. And there is a shortcut because I usually use PHP config by default, so I just created a name constructor here, a static function, which simply says, okay, with PHP config default, which is basically what we are seeing in the left. So I don't need to define this all the time. I simply define this, and this gives me the default behavior. There is a bit, say something a bit more complex and even fun. We are not going to go super deep, but just to give you an overview, you can have, so Gacela has an auto wiring for the Gacela classes. So in the factory config and dependency provider, you can actually inject whatever you want, even interfaces on the constructor of these Gacela classes. And then if it's an interface, actually, Gacela doesn't know what do you actually want with this interface. So you can specify to resolve to whatever you want when Gacela finds some interface. This is for Gacela context, not in your domain or infrastructure we saw earlier. And this is really interesting that you can actually communicate between you remember that we have the possibility of using this configuration from the bootstrap directly or in a file, right? So we can actually communicate these two files somehow when adding an external service from here. When you are when you are bootstrapping Gacela, you can add an external service with a key, and you can retrieve that service, the same object, you can retrieve it later to when using the Gacela PHP file. This is just something I found really useful, interesting. For example, to use the real Symfony kernel when using Gacela in a Symfony application already, where you can use the Symfony kernel and the real object of the entity manager, and then later you can auto-inject, Gacela will auto-inject the entity manager from Symfony to the factory, and then you can inject the real Symfony to your own repositories. But that's too detailed. Let's go to something more smoother and chill. So suffixes. This is something I got a question last year when I was presenting Gacela in other places. And some people ask, okay, but what if you have already this concept, but with another naming? Actually, it wasn't working before because it was hard-coded, but I just make it extendable. So you can actually have different suffixes for the for factory and config and dependency provider. So in this case, as you can see in this module example, we have the entry point, creator, conf, and binder. Okay, but these are actually the same. These are synonymous for the real Gacela classes, let's say, and you can have as many as you want. There is also another super cool feature I find, the project namespaces, where you might, if you are a Spryker developer, I am 100% sure that you have encountered this in your career, because what's happening if you want to extend, override some Spryker code, you simply extend the Spryker class, right? And then you put it in your in your big set or your custom project namespace, and then you have the same class, and then you extend the Spryker class, right? So with this is something similar. You can actually have a dependency, a third-party module which has a Gacela project, a Facade factory, and then you want to actually override something from the factory of the third party. So as simple as having the same module name in your main project namespace, Gacela will find that one because this one has priority over that one. So when you use the facade from the third party, the facade will, when using the factory from the facade will use your factory in favor of its own factory. And then, as you can see, there is a lot of resolving and class how is the name? A class resolver. When you have a factory, a facade, okay, which belongs to whom? And so I built also a file cache. So by default, I think it's disabled, but you can enable it, and you can also specify where do you want to store that cache. And then this will produce something like this. So it will produce a simple array, key value array, where it will specify the factory of, will specify what do you want and where it is find, where can it find it. This is a real example from the Felt project, where it's having the class names resolved by Gacela and also some custom services, which is another feature we will see later. There are some internal events. This is just for really cool to see what is happening inside. So you can register a generic listener, and then you can simply do a screen or just check what can you do with the event. And you can register a specific listener for some events that are happening. These are all of them. We don't need to go through them. There is also a possibility to reset all in-memory cache, because Gacela is using a single dot pattern where everything is living in the memory to optimize everything. But this is not really cool for testing. Usually, when you are testing the facade and then the whole thing is created, you don't want to populate the same storage, the same memory, the same singleton everywhere, because it's a new running, a new living thing every time. So with this simple flag, let's say, simple call, it just simply erase everything and then start from scratch Gacela. So this is really cool for feature testing, end-to-end testing. And then the last feature I'm gonna show you, which is also kind of new. We can extend services similar as we do. It's a bit more powerful, but it's very similar as what we can do in Spryker. When you have a service, let's say, for example, let's focus on the right side. This is like a module. I just compress everything in one screenshot. But this is like a facade file, a factory file, and dependency provider. So the facade use the factory to get something there. Okay, this is the factory of the module. Then this is the method, and the method here, the factory can get and provide dependency. Okay, this is the key, and the key is setting here. And then this is the dependency provider, which is actually setting a service, an array object, let's say, which has a value 1 and 2. Okay, so then from Gacela PHP, right, from the Gacela config, remember, we can extend a service. We pass the name of the service, which is this one, array op, well, we're accessing the constant here, dependency provider array ops. And then the second argument is a callable, a function, which as a first argument receives that object. So this one here. And then you can do whatever you want to that object. And so this is why this is cool, because then when I'm actually using Gacela, so I'm just calling my facade, and then I call that method, get array as object. So this one, remember that this method, it was simply retrieving the service which we defined here. So at this point right now, my array object has 1, 2, and 3. So why? Because it has originally 1 and 2, but they extended in my service, so now I have 3. And you can imagine what can you do with this? A lot of cool things. I have more features, like you can, the same as we can have different Gacela files for different environments, you can also have different config files for different environments, and it's follow the same pattern with the minus and then the environment, and then it will load first the original, and then it will load the one from the environment, and it will override the values. There, as I mentioned, there is auto-warning dependencies into the factory. There is a awesome feature, dot block resolver aware trait. This is really cool to, for example, if you have in your infrastructure layer some commands, symphony commands, and you want to call the facade from the module, there you can simply specify the facade in the dot block, and it will resolve it. And then it will cache that thing in the file, so it doesn't need to do some nasty looking, searching later for where do actually you want, just simply go to the cache and it will just resolve it. There is also, you can override the existing resolve class. This is pretty awesome for testing as well, because you can actually override dependency you can override whatever facade, whatever Gacela class you have, you can override it with some fakes, and you can mock them, and even you can add some globals, but this is too advanced. And there is I don't know how much time do we have. I think I already spent most of the time. I was thinking about, can I stop sharing and then start sharing again? Because I want to share only. Oh, well, no, doesn't matter. So let's go here. So I will just show a super easy peasy demo of how to use Gacela. First, you need to have it required, of course. And then I have here some PHP unit and HTTP client. This should be actually in the required. But it doesn't matter, I think. So, okay, this failed because the comma is. Okay, there you go. So we have an app here. Okay, what is my app doing? There you go. So let's go. I have here some cheating for sure. So my app, I want my app to have a module, which is a comment module, let's say, a facade module, and then I want to check if the message is a spam. And if it's spam, it's true, otherwise false. And then I execute this, and of course it's saying, no, it doesn't exist, this class. Okay, let's create a class. So here we create the class, source, and inside the source I have the module, which is a comment. Yes, and then here I have a class, the facade. There you go. And this need to extend the abstract facade. Perfect. And I need the namespace. Comment. Of course, I need the comment. Yes. Now, so now we are there. And now it says the method doesn't exist. Of course. Let's create it. Okay. And this one will return true. Just checking. Yeah. It's not available. There you go. So at least the communication now is flowing from the app to the module. So now we have the spam there. Let's go and cheat a little bit again. Let's go here. Let's copy whole thing. Namespace. We need to remove namespace. Use function. There you go. So now we have created the facade method, which is spam there. Then we have defined the factory of the module, and then we are designing now the code without having the code. But this is what we want. We want to create a spam checker. We want to check if it's spam. All right. So what we need now, we need a factory. So let's create a factory, and the factory need to extend the abstract factory. There you go. So we can close that one. On the factory now, we need to have a spam checker. Okay, what is this spam checker? I just want to go faster by copying this, as you can notice. Factory. So there you go. So this here. So by designing this, now we can see. Okay, I need a HTTP client, and I need an endpoint. Let's do the endpoint first. So for the endpoint, I need the config. Let's create the config then. Common config. Okay, no. Before creating anything, before actually doing anything on this, what is the spam checker? I think that's worth mentioning. This is something from the domain. So let's create a spam checker in the domain. And then how do you want to actually create that? Let's do super quickly some tests. Unit comment. Yeah, and then the domain. There you go. And now let's add the test. Ideally one by one. but right now I think it's gonna be fun if we just simply continue treating like this. We have this and that. So by designing the test, we can realize that we need these two things. We need a HTTP client interface and an endpoint. All right, so this now is the things that we need. We need the interface, which is something like this. And we need the spam checker and this dependency. All right, so by having this, we have a method. This is the method, this is the spam checker that we want to create. Let's copy the whole body now. I don't want to spend time thinking about that. So now we have defined our domain logic for the spam checker. Okay, and why is complaining? Because we are missing what? We have one too many here. There you go. Now we have a spam checker, which is there. We are creating in the factory the domain spam checker. And now is when we come here and we say, okay, now we actually need demo. There you go. We need the endpoint from the config, and we need the whatever is the dependency provided, the external HTTP client. Okay, let's do first the config. We were doing the config, and the config is here defined. So if I do this add method, it will find it quickly here. And here again, abstract config. As you remember, we have seen from Gacela itself, we have used the abstract facade, then the abstract factory, where we are right now, and then we have an abstract config. Okay, and then from this endpoint here, I'm gonna take it from here again. Config check. So we have the method that we are using in the factory, right? This one here, and now is the thing. Okay. Oh yeah. So here I have the endpoint, and from the endpoint I need a key from something from the environment or whatever. So this is something that this method it will get the key, the value from this key from the config. So what is the config defined? If you remember, we have the Gacela bootstrap, and here we have this PHP config default, which is by default using the config directory. So let's create that config directory, and here whatever is fine. No, I don't want a class. I want a file. Default PHP. Yeah, and here it's just enough to have this returning this key and whatever you have here in your value. And this is the key that we are getting, and we are appending to this place, and we are building the endpoint that we are passing to the spam checker when we are building in the factory. That's done. Now we need one more thing, which is the dependency provider. So let's create the dependency provider. And this needs to extend the abstract dependency provider. There you go. And here we need to add something which is mandatory, because it's, we need to provide the module dependencies. That's the only thing. There you go. And now, so where is this guy here? Yes. So basically here what we are doing is we are specifying, this is the key that we are using outside in the factory. There you go. Now there are no warnings. So here we want to get the provider dependency that we set in the dependency provider. And so if you check what are we setting in the container of the module, we are setting this thing. So this is the extra dependencies of the module, right? This is the Symfony HTTP client, whatever it is. So actually, I want to store this. I want to have this in my infrastructure layer, and here I will create a class. And this class will extend the interface of the domain. There you go. And now we implement the stub, and this is the interface method. And here we have it. We are using the one from the HTTP client from the Symfony component. This is the one that we requested here, right? This is the super outside of my module, actually. But I don't care. This is something that I'm creating in the dependency provider here, import. And this is the one I'm setting here. And this is the thing that I'm getting in the factory, right? and I'm injecting it into my domain span checker, which is an interface of my domain. Beautiful. We could test it like this, like manually, but how cool it would be if we have also test for the facade, right? So what about creating this is the last thing. What about having a feature? And how can you actually do such thing? So I have a comment span. Here, let's go. Comment span test. And I think I will copy the whole thing. Yeah, this is gonna be a bit complex, but I hope you can follow. Here we are using in the setup. We are using the config to just say, okay, reset the memory cache. They make sure that every time I'm starting with something fresh, and also just hard code the config key value of that one with some fake key. I don't want to have a specific file like config default file or whatever here. I don't mind. Just put something there, and then I have either you have one and then another, but yeah, let's stay with one. We want to test if it's span or not. And to do that, you can actually override an extended resolver class. And what do we want to override? We want to override the dependency provider of the module, which is this one here, because this one here is creating the real infrastructure thing that we want to mock. So what we want to do is to create a fake, let's call it here fake, for example. Here we call class a fake comment dependency provider. And why it's a fake? Because it's another, here it is. Is an abstract dependency provider from Gacela again. But when we are setting the HTTP client, we are creating a fake HTTP client, right? Not the Symfony, but the fake one again. So let's create another fake here, and you will see now the magic happening, because the fake one is actually something that's like a stupid mock, which is implementing the domain interface, right? And then in the method of the interface, we are simply returning what we just passed it by the constructor, the content. And where was this set? This was set in the fake dependency provider just here. And what is this HTTP client content? We just pass it via the constructor again to the fake. And where is this set? In the test itself. So the beauty of this is now that, import this one, that here in the scope of the test, we are defining what do we want to actually return when we are using something from the infrastructure layer outside of the scope of the module. And with this, when we call the facade, we are mocking that beauty, that complexity thing. Yeah, okay, now probably something is missing the namespace. Yeah, exactly. Namespaces. One sec. I forgot to copy the namespaces. This is there. It's missing it. Here, this one. Okay, this is not needed. And now it's missing that one. Yeah, now import it. Now import. Done. There you go, green. And if we run the other one, both green, both perfect. So here we are taking that assert that is true if any test, because I don't care. I care about the result of the endpoint, because the result of the endpoint, remember, is the thing that we are using in the client that we are passing to the domain. And this thing here is the thing I care. And then I'm comparing the content with some whatever logic I have. So if it's true string, is true, otherwise it's false. And that thing is exactly what I am taking advantage of my mock. If this is true, then it's true. If this or something else, it will be false. And I'm testing the facade entry point. So I think that's it. Well, yeah, that's the live demo. Do you see still? I think, yeah, I'm still showing, yes. So with this, you can see the potential of Gacela. What can you do like in a couple of minutes, entire module, and then you can communicate the facade between each other via the dependency provider, the same idea as I just did with the infrastructure Symfony HTTP client. The current status of the project is actually really cool. We have over 100 starts, and I am really I'm aiming for code quality, and not just because I say so, but I rely on tools. For example, Scrutinizer, which gives a note of 9.9 out of 10, and also code coverage. So the whole project is coverage like 91%. I really find a hard spot to add more tests because it's like everything is tested. And yeah, we have so far. We released this year the version 1.0, which is a promise of working and compatibility working with the version 1 at least. And thank you very much. You can find me in GitHub, of course, but in Twitter, and there is also a little Twitter for the Gacela project. And there is the whole documentation about the project in the gacelaproject.com webpage. And if you have any questions or any remark, you can let me know. And we have also a dedicated channel in Slack, and hopefully in the next, in whatever. Thank you.